So today we're going to finish up the law of sines, and we're going to look at the SSA case, or this is also referred to as the ambiguous case. Now the tough part with the SSA case is that we first have to determine how many triangles we're dealing with. Depending on the length of our sides compared to our height, we can have either one triangle, two triangles, or even no triangles. So, in order to decide, we first need to know the height of our triangle. And in order to find the height, we're going to use the equation h equals n times the sine of whatever angle we're looking at. Okay? Now, we're going to call n as like the adjacent side, O is like the opposite side, and h obviously, well, that's the height. So here is my angle, okay? And when I compare the opposite side with the height, if the opposite side is less than the height, we have no triangles. And when we have no triangle, we're done. We don't have to go any further. We don't have to find any of the other sides because there's no triangle. Now, if the opposite side equals the height, we have one right triangle, and then we could use the Pythagorean theorem or whatever we might want to use in order to solve that right triangle. That would be a little easier. And the last two cases, if the height is smaller than the opposite side, but the opposite side is smaller than the adjacent side, okay, so we have this thing going on, then we have two possible triangles. Now, this is the worst case scenario because we would have to solve for not one, but two triangles. And finally, if the opposite side is greater than the adjacent side, then we have one oblique triangle. All right? So let's start by first deciding how many triangles we have given specific information. So first example here, let's draw what we would hope to be our triangle. A, so side A would be 10. Angle B, side B is 6. And angle C, we don't have anything to do with C, but we do have angle A as 30 degrees. So when I think about where my angle's located, here's the adjacent side. So this is my n, okay? The opposite side would be the 10. So let's find my height. So h equals n sine of whatever my angle is. So plugging everything in, we would have 6 sine of 30. So h would be 3. Okay. So when I compare that to the opposite side here, we see that h is less than the opposite side, but that the opposite side is also greater than the adjacent side. So that would mean that I have one triangle. Okay. So if the height's less than the opposite side, but the opposite side is greater than the adjacent side, we have one triangle. All right, second one. Set it up. A, side A is 8. Angle B is 30. Side B is 5. I don't know anything about C. So again, this would be side angle, right? SSA. Sorry, I didn't say that in the first one. SSA, right? So here would be n, right? The adjacent side. Here would be the opposite side of my angle, so the O. Let's find the height. N sine of whatever my angle is. So h equals 8 sine of 30 degrees. Again, sine of 30, think back to the unit circle, is 1/2. So h would equal 4. Alright, let's compare h to the opposite side. Here, we see that h, my height, is still less than the opposite side, right? So let's compare the opposite side to my adjacent side. Here we see my opposite side is also less than the adjacent side, that n. So in this case, we would have 2 triangles. So see the difference between example A and example B, right? The height was less than the opposite side for both of them, but then it's comparing the opposite side with the adjacent side. If the opposite side's greater than the adjacent side, 1 triangle. The opposite side's less than the adjacent side, 2 triangles. Alright, last one here. Let's see how many triangles we have. A, nothing going on with A. Here's B, side B is 10. Angle C is 30, and side C is 3. So, here would be N, here would be O. Find our height. N, which is 10, sine of 30 degrees. Again, sine of 30 is 1/2, so the height would be 5. So let's compare that to the opposite side. Here we have h is greater than my opposite side. When that happens, we have no triangles. Alright? So let's compare, or let's take this a step further now, and after we determine how many triangles we have, then we're going to use the law of sines to solve that triangle. Alright, so let's start with A. Again, let's set up our triangle. Angle A is 49 degrees. Side B is 5 miles. Side A is 9 miles. And we don't know anything about C. So here would be the adjacent side, here would be the opposite side. So let's find the height. H equals N sine of 49 degrees. Punching all that into your calculator, you would get your height equaling 3.8 miles, right? So let's see what all that tells me here. So the height's 3.8, my opposite side's 9, so h is going to be less than the opposite side, and the opposite side is going to be greater than n. So that tells me I have 1 triangle. Okay? So let's solve for that 1 triangle here. The one ratio I have deals with A. So I know that I have the sine of 49 degrees all over 9. And I have side B, but I don't have angle B. So we can use the law of sines to also find the angle measures if we're given that side. We're just going to have to use inverse trig again. But we have our calculators, which makes things a little bit easier on us. So we're going to find angle B here. And I know that side B is 5. So I don't really need to cross multiply here, because I need to get sine B by itself so I can take the inverse of it. So I'm just going to multiply the 5 over. So sine B equals 5 sine 49 degrees all over 9. So in your calculator, to find B, so B would equal sine inverse, so sine to the negative 1, of 5 sine 49 degrees all over 9. Okay, type that all in, and you would get an angle measure of approximately 24.8 degrees. Now we have angle A and angle B, so we can subtract all that from 180 to get angle measure C. So angle C is going to equal 180 minus angle A minus angle B. So angle C would leave me with 106.2 degrees. Alright. Alright, last thing I need to find is side C. So, using the A's, so sine of 49 over 9 equals the C's. Sine of 106.2 over C, cross multiply. And divide. Punching all that into your calculator, again, make sure you're in degree mode, but side C would equal 11.5, and in this case, miles. Alright, so that is when we're dealing with one triangle with the ambiguous case. Alright, let's move on to B. Let's set up our triangle here. Nothing going with A. Angle B is 65 degrees. Side B is 8. I don't know angle C, but I know side C is 10, so SSA again. So here is my adjacent side, here's my opposite side, so let's find the height. So 10 sine of 65 degrees. So my height would be 9.1. So let's compare that to the opposite side. So here, the opposite side is now going to be less than the height, which can't happen. Okay? So we would have no triangle. And when that case comes up, we're done. We can't solve for the triangle because there is no triangle. Alright, last problem. And since we've looked at a case with one triangle and a case with no triangles, I'm going to assume that we all know what's coming, and we're going to have to deal with two triangles. So let's start by figuring out how many triangles we have. So A, side A is 40 meters. Nothing with B. Angle C is 37. And side C is 28. So we have side angle. Here is the opposite side. Here's the adjacent side. So let's find the height. 40 sine of 37 degrees. Punch that into your calculator, and you get a height of 24.1. So let's compare that to the opposite side here. So the height is going to be less than my opposite side, and the opposite side is going to be less than the adjacent side, which tells me I have two triangles. Okay. So let's deal with the first triangle first. So I know the C's, right? So that's my given ratio. So sine of 37 all over 28. And I know side A, so I'm going to find angle A for the first triangle first. So sine, and I'm going to say A sub 1, okay, for angle A for the first triangle. And I know that the side length is 40. So we're going to multiply the 40 over. So we would have sine A sub 1 equals 40 sine 37 over 28. And again, to solve for a sub 1, we're going to make use of our inverse trig. So a sub 1 equals sine inverse of 40 sine 37 degrees all over 28, which would give us an angle measure of 59.3 degrees. Alright. Now, we can find b sub 1 since we have a and c. So let's go ahead and do that. So it all has to add up to 180. So the measure of b sub 1 would be 180 minus a sub 1, 59.3, minus c, 37. So b sub 1 would be 83.7 degrees. Almost done with the first triangle. Now I have angle B. Now I just need side B. So again, we're going to go back to the law of sines. So we have sine of 37 degrees over 28. And now I'm going to do the b's. So sine of 83.7 all over little b sub 1, right? So the side length for the first triangle. Cross multiply. So b sub 1, sine 37, 28, sine 83.7, and then divide the sine of 37 off. Punch all that in, and we'll get b sub 1 equaling 46.2 meters. Alright, so that's the first triangle. Now, we have to solve for the second triangle. Now, the way we're going to do this, we're going to take the angle measure for A, and we're going to subtract it from A at 180. Okay, so that'll give us the second angle A. Okay, so angle A sub 2, and we're always going to do this. Okay, so 180 minus the 59.3 we found from the first triangle will give me a new a sub 2 that equals 120.7 degrees. Alright, now using the new angle A, we'll find b sub 2. So b sub 2 would equal 180 minus a sub 2, so 120.7, and then minus c, which stays at 37. So b sub 2 is now going to be 22.3 degrees. Now we just need to find side B for the second triangle. So again, I'm going to stick with my c's. Okay. So sine 37 over 28 equals sine of 22.3, right? I'm going to do the b's. Little b sub 2. Cross multiply. And divide. Sine 37. And cancel that out. So b sub 2 is going to equal 17.7 m. Alright, and then we're done.